Welcome back everyone to another Technique Coding programming tutorial. In this video we are continuing where we left off in the part 1 of the UIKit Navigation Coordinator pattern. This is part 2. In the previous video we set up the basic project. We went kind of over a little bit about the coordinator pattern. I'm going to retouch on that here in a second. And in this video we're going to create the authentication flow and then show how to actually go from that to the main flow. If we have more time, I'll keep going with that, but without further ado, let's get started. So just to hint a little bit, just to get deep dive a little bit into the coordinator pattern. The coordinator pattern, if you don't already know, is a method to handle navigation logic within iOS code bases. For those of you who are Android developers, there are a few people who kind of took this and made it in an Android app, but it's a lot more boilerplate for certain reasons I won't get into right now. But in any case, there's a few benefits to this pattern. One of them, a few of them being traditionally in Swift and iOS before SwiftUI, most navigation was done with segues. That was the original recommended way that Apple told people to actually create navigation logic through storyboards and segues. It was very visual. Apple's very visual, but what ended up happening was you got this kind of monster of unreadable configuration code in the storyboard file. And if a single person on the team opened the file, it would adjust it and it would require an update in version control. After all of that, teams started doing what was then called just programmatic UIKit, and they were just creating everything programmatically with views. So the coordinator pattern was created in order to solve a lot of the navigation logic to help avoid some of the downsides to using segues. And the nice thing about this is all of the navigation logic is in code rather than segues, and it's all much more easily version controlled. A couple other benefits to this too is all the navigation logic is actually handled with one object, not scattered throughout the code base. What you would have found originally if you were to use segues is much of the navigation code was sporadically kind of sprinkled across the code base because there were these prepare for segue function calls within each UI view controller that people used to actually handle navigation logic to transfer data from one screen to another. It's very cumbersome. But the coordinator pattern actually allows us to handle things like, navigation, but also dependency injection and data flow much more easily with this pattern. Also, the main benefit of the coordinator pattern is you get all of these flows composed into its own navigation logic, kind of like the idealistic composable object. So a flow is represented by a coordinator. And that coordinator, you can move it, mix and match. You can even embed it in other coordinators for a high reusability of that coordinator. This saves drastic amounts of time and energy when it comes to complex coordination when it comes for navigation. Can't stress that enough. When you are actually out in the field and you are creating complex navigation flows, this pattern is going to save you a ton of time, stress, and probably even your hairline. So knowing this is a powerful tool as an iOS developer and can leapfrog you in front of other people in your career. So I highly recommend you know this. So why UIKit? Why are we going over UIKit? Well, for one, I'm going to go over the SwiftUI version of this in a future series, but I always start out with UIKit right now rather than SwiftUI because as an iOS developer in the current state of things in the field as of 2025, almost every single code base you will see is legacy code. It's very rare you'll have what's called a greenfield project where you are creating code from scratch. In those cases, it is up to you to decide how you want to actually architect the app, whether or not it's going to be straight up SwiftUI, if it's going to have UIKit navigation with SwiftUI views. That's up to the individual developer around the context of the project to decide. But I start off with UIKit primarily because the vast majority of projects out in the field in the real world are going to be legacy code bases. That being said, all of the views I make are wrapped in UI view controllers and used within this UIKit Coordinator navigation logic. The other thing that a lot of people just, if you've been in the development field for more than 10 years, like I have, I'm showing my age, I know. If you've been in the programming field for more than 10 minutes, you will see these odd ebbs and flows, these cycles where people relearn old concepts and they consider it new. One of the reasons I like UIKit personally is because it's actually imperative programming. So right now there's a lot of hype around reactive programming and SwiftUI's declarative programming. It does make your life a whole lot easier when you're using simple views. However, imperative programming means that we are coding every single little tiny interaction, and that means it does exactly what we want it to do. There are some cases, not all, but there are some cases where allowing SwiftUI to handle the magic behind the scenes is actually going to cause you more harm than good, or it could cause you to lose your hairline. There are certain things that SwiftUI, like a lot of us say out in the field, SwiftUI is amazing until it's not. In those moments, imperative programming can be very useful because you're not allowing Apple to dictate how things actually act and flow within the app. So there is a case to be said for imperative programming in certain situations. So I always show this as a benefit for my viewers to get kind of like the best of both worlds. And you can choose on your own time, in your own projects, in that own context, what is best for your situation. Also, the reason, like I mentioned before, the reason I really like UIKit is because you can actually utilize UI view controllers and SwiftUI views. So you kind of get the best of both worlds. The downside of this is you have to know both. Some people just don't want to know both. Some people just want to do greenfield projects and start off from scratch. I'm not here to tell you what to do. I'm here to give you the tools to do what you want to do. I do have preferences, and I do allude to those from time to time, but in any case, here's the UIKit version first, and then we'll do SwiftUI in a future video. Cool. So moving on, let's go over to our Xcode project here, and let me remove my face so you can see stuff a little bit easier. So in the last video, what we ended up doing was we created this app right here. The target version of this app looks something like this. So we've got a very simple navigation screen. You can hit submit. You can go into the home screen. There are different screens that we can navigate to, such as your account. We've got a couple edit screens. There's quite a few screens and navigation logic in this. We're not going to get through this whole thing today, but what we are going to get through is this auth-flow right here. We go back and forth. You can hit submit. And let's get on that. Okay, so just to give you a higher level overview again, this is the auth-flow. So when we're looking at our total navigation logic here, we've got the root level, which we just created through the ApplicationCoordinator in part 1, and we are creating the auth-flow right here. This will eventually lead to the main flow by way of the user handling the login action, and then it will go back, delegate back up to the ApplicationCoordinator, and then it will navigate the user to our main flow. Okay, so let's get back into it, shall we? All right, let me give us a little bit more room at the top. Cool. So in the last video, we finished this BaseCoordinator right here, and this is just the base class that all future coordinators will inherit from. We've got each coordinator can have child coordinators, and it has a presenter, which is the most important concept with a coordinator, along with the start method, which is required to be implemented by all subclasses of this base class. This is where the first screen usually shows up. Then we created a ApplicationCoordinator. All this does is it creates a UI window, and it presents a screen, which is our Hello World screen right here. That's all it does. The presentation logic is within this start auth method, and I usually organize it into a nice little extension called showing screens. And all we're doing is we're saying presenter, set view controllers with only one controller, which is our test view. As far as showing this on screen, just to reiterate, we're creating the UI window, we're creating the application coordinator in the app delegate, and we are starting the application coordinator. It makes the app delegate nice and clean. When we go back to the application coordinator, we're just manually creating a presenter, which is a UI navigation controller. Then we just call super.init, and then we are setting the root view controller on the window. This is how you actually create, set the view that can be seen, and then we say make key invisible to actually show it on screen. And then we are just starting auth, and then we are presenting. So from here on out, the first thing we need to do is actually start to create our screens. So we're going to come down here, and we're going to go into, we're going to eventually delete that, but I'll leave it there for right now. And we'll say login. And then template. This is going to be a SwiftUI view. Login view. Cool. Okay. So for this, let's make some more room here. For us. Okay. So for this login view, what we're going to do is we're going to have a v stack. And this is going to look, this is our target right here. This right here. So it's just going to have two fields, a title, two buttons. That's it. We are going to create custom views for these two fields just so we can reuse them. So first things first, we are going to just create a all right, let's just get something on screen for the moment. Cool. Okay, so now we have basic text down there. So next thing we want to do is we want to create a text field. And just as a placeholder for the state, we're going to say var, we're going to have at state var email equals a string. It's going to be empty right now. And we are going to say text field text email. Okay. And it should give us just a, and it doesn't want to actually work right now. It's probably because there's probably build error, and there's not. Okay, so in this case, basically what we can do is we can try to refresh it after rebuild, and there we go. Sometimes SwiftUI previews break, so you have to actually rebuild it from like using the actual rebuild options, not the previews. So we now have a field down here. It's called email. Now we need to style this. Now, instead of me doing it right here, I'm actually just going to go and build a custom view. You can do a new group, not from selection, new group. And this is actually going to be here. And we're just going to call this shared views. Move it down. We're going to do new file, SwiftUI view. We're going to call this one email field. So because we're going to have this in both the registration screen and in the login screen, we just want to reuse what we've got here. We're going to say at binding var value string. Then we're going to say var placeholder for the placeholder text. And because we're primarily going to use this for the email, we're just going to default it to email. And then we're going to have text field. Title key is going to be the placeholder. And then the text is just the value. But then we're going to say text field style, and we're going to have our own custom text field style in here to handle things like the borders on it. So the borders, the padding, all that. So we're actually going to create another group inside the shared views called text field styles. And this is all subjective. Like, you can organize this however you want. We're going to say new Swift file, default text field style. And then for this one, we actually have to say, first off, we need to import SwiftUI. Come down a little bit. Say struct default text field style inherits from text field style. Func. This is one of those things where you just kind of have to remember the signature of this function. I always forget this. Don't feel bad if you forget how to actually write a function or forget what the signature is. That's why we have documentation. I know sometimes in college, professors think you have to memorize everything, or else you'll be a failure out in the field. I had a professor at one point in my school that made us remember over 50 equations for one test that was only going to use 5 of them. Not my opinion to say that, or it is my opinion that that was not needed. Okay, run a rectangle, corner radius 5. And I'll be going over this here in a second. I just want to get this out here. And then just so we can see this, what I'm going to do is I'm going to actually write a preview. So using the preview macro, we can do something like this. And then that should load and give us a little bit of a preview here of what we just did. Okay, we're going to have to rebuild and rerun this. Okay, so just for the sake of the video, I'm going to show you what the issue was. We just forgot a couple parameters here. So back in our email field, we just have to add in the default text field style, and then just a placeholder for the value here. And then we should be able to build. Succeeded. Default text field style. We should be able to refresh the SwiftUI previews and see it on screen. Cool. Okay, so let me explain what happened here. So we're creating a default text field style that we can pass into the text field style property here. Attribute. Anyway, so once we do this, this is going to apply whatever's in this default text field style to the text field. This is just a way to share styles. So what we did is we just gave it some padding. The padding is actually helping us to create some space between the actual text itself within the field and the edges of the field. And I'll let this render here for a second. Okay, so yeah, so let me zoom in for a second, and I'll go to here so I can zoom in. So the padding helps us edge this placeholder away from the edges. If I said horizontal, like 25, for instance, it's going to move the email field right 25 points. The clip shape, the reason why we have a corner radius rectangle here in the clip shape and also one in the overlay is because the overlay handles the border, but this clip shape is the thing that's actually preventing what's inside from going. Let's see if I can actually show this. So basically, if I made the background color within the field blue, for instance, and I did not have this clip shape, you'd see little tiny edges coming out. I don't know if you can see this little tiny box. You'd see some blue bleed out into the corner. So we need this clip shape to actually clip the corner radius so nothing within the field actually bleeds out to the squared edge. In any case, let's move on. So we're back here in the email field. So now that we have that, we can actually move on and say .text content type. Now this is actually pretty important when you're creating fields for login, pretty much anywhere in the iOS app, but primarily when it comes to creating authentication flows, auth screens, logging in registration, and the text content text input auto capitalization, we're going to say never. The text content type is important, actually, along with the text keyboard. There's a keyboard type. We're going to say email address. There we go. So the text content type tells the system what this field is what its purpose is. This is very important when it comes to creating apps that utilize password autofill. Apple has this nice feature called password autofill where it will give you suggestions. You've probably seen this in other apps where it says, do you want to use a strong password? Do you want to use an existing password? And it will actually show you a password suggestion or account suggestion on top of the keyboard. It does that through contextual identification on the fields itself. So the text content type is going to be used to help facilitate that. I won't go over too much more of that in this video though. Then obviously since it's the email field, we never want to auto capitalize because some backends just don't check for that. And then we're just helping the user out by giving the keyboard type to email address. So we want to do the exact same thing, except this time we want a password field. So we're going to create a new SwiftUI view. Navigation stuff will happen pretty quickly once we finish these fields up. And feel free to skip ahead if you need to. This one should be pretty short and sweet. We're going to say, we're actually going to copy and paste the email stuff here. The value is for field. And just for the sake of it, let's close out some of this. Placeholder is going to be password. We're going to have a VStack. And it's going to be secure field. Oh, I gotta. Text field style. This is still a text field, so everything we did on the email field, we can still do to this one. Text input auto capitalization, never. Password field. Value constant, and we'll just give it an empty string. And then that should load here in a second. And there we have it, the password field. So now that we have that, let's go back to our login view here. And we can replace this text field with an email field. And we can say email. So now that's, we're just going to give it some padding here, and we're just going to say, because this is going to be a full form, we're going to put the padding on the VStack. We're going to say, actually instead, let's do frame 250. There. So instead of using padding, because in this case, you can use frame to say, I want this to be the exact width across every single device this runs on. Frame is a good way to do that. I could use padding, but if we did use padding, we could do something like horizontal. We could say, we'll give it 50 points, I guess. That still looks fine. Cool. So underneath the email field, we're going to say password field value. We're going to copy this. Ideally, you would make this private. And then that should pop up. Cool. Let's zoom in just a little bit here. So we've got our two fields all set, email and password. Now, if we move on here, what we need, if we look back at our app, we just need two buttons, submit and register. So what we're going to do is we're going to say button register. For right now, it's not going to do pretty much anything. And then at the bottom, I'm going to say button. Oh, this is actually submit. We're going to copy and paste that. No styling on this one. We're not going to be fancy. Now to spread this out, we're going to give this a spacer up right here. And then to push it back down so it's more center, we're going to put a spacer up top as well. Cool. And that should look fairly close to what we have in our final product. It does. Cool. So now what we want to do is we actually want to create a view model for this. So the view model is going to have the state, but the way I do it, and people can debate me on this, a view model traditionally doesn't deal with logic too much or actions, but in SwiftUI, what I like to do is I like to delegate the actual action to the view model to have it handle whatever it needs to handle. The view model is essentially, the way I do it is it's the proxy between almost everything between the view and other things. So you could probably call it more of like a view controller, although that's kind of like not true MVVM. And the view model still actually gives us the view's state. So I do like to call it view models, but it's kind of a shimmy in there that to give it some extra responsibility. But in any case, I do create view models for my SwiftUI views. So let's go ahead and do that, and then we'll replace some of this stuff. So we're going to say new empty, so new file from template, SwiftUI file, login view model. Now, those of you who have seen my other videos, you know that I actually like to namespace these a bit. So what I do is I say extension login view, and then I just say class view model observable object. Then when I go into the view, we can replace this with at state object var view model, and then we can just call it view model rather than have to worry about another name. And this is kind of nice. Again, subjective. It's just the way I usually do things. You can do things however you need to, just the way I do it. Before I go forward with this, we're going to make our lives a little bit easier, and we're going to start creating core objects to inherit from. One of them, new group, I usually call this directory core. Let's clean this up a bit. Inside core, we're going to have two things. We are going to have a base view model, and we are also going to have a hosting controller. And there's these two will work in tandem with each other. Class BaseViewModel, weak var hosting controller, UI view controller. What I'm doing here is each BaseViewModel is going to have a hosting controller. Because we are wrapping all of our SwiftUI views in hosting controllers, this will actually automatically give us access to that UI view controller when we have to do things in that UI view controller. It's a convenience method. I think it's pretty handy. But the reason we can use this is by creating our next base class, which is the hosting controller. In this one, UIKit, we're going to say we also need SwiftUI class, hosting controller. And we're going to use generics for this. So content is the view, and the view model, base view model. And it's going to inherit from UI hosting controller. And I'll explain this here in a minute. Okay, so this is a convenience. If we didn't have this, and something's going on here, designate initializer for init. Let's see what this error is real quick. Super. I probably spelled this wrong. View model. No. When you follow the auto completion too much and you make this little mistake, something's happened. Okay, so if we didn't have this, then we would just have to write a little bit more boilerplate code for all these hosting controllers. This allows us to just define a type of view and view model, and then we can just pass in the view model for each one of these things. The init coder, if you're not familiar with this primarily occurs if you're working with nib or storyboard files. We don't have to worry about it. We also shouldn't be using this. So we put in a precondition failure to crash the app intentionally when a developer tries to implement this for some way, shape, or form, or tries to instantiate this from a UI storyboard for some reason. But in any case, what we're doing is we're saying that the generic type content is going to be of a type view, so we can conform and actually call the super.init, and then we are saying that the type VM view model is going to be of a type base view model, and then we are just adhering to the UI hosting controller. We are subclassing it and saying that the content that to expect is going to be of type view here. I'm not going to go over too many generics right now. You can look at that in your own time, or maybe I can make a video on that in the future. This right here, this line, this viewModel.hostingController equals self, is how we can have access to this hosting controller. So the hosting controller, this is kind of cool. The hosting controller right here has access to the viewModel via this means right here, and the viewModel also has access to the hosting controller through this. Very important. The only reason this works is because we have weak var right here. We do not want to create a strong retain cycle. If this weak declaration right here did not exist and we just said var, we have now created a strong retain cycle, which creates dangling memory inside the app, and you don't want that. So we have to say that the hosting controller is a weak var and it's optional, so this works properly. kind of a little bit, if you're not used to doing things like this, but it is extremely convenient once we get working with this. So going back to login view model, what we're going to do is we are going to say this inherits from base view model, and we are going to then create our two email and password fields. I'm just going to type this up to save some time here. We don't currently have that delegate, so what we need to do, protocol. Okay, for those of you who haven't yet maybe heard of the delegate pattern, all this is we have an object that adheres to this protocol that we basically give its instance will be set as this weak var nav delegate to handle these actions. That's all it is. Our coordinators are the ones that will adopt these protocols, and they will handle the navigation. So basically what we're doing is we're just delegating all navigation action to the nav delegate. So then what we need to do is we don't need an initializer now for that. So what we're going to say is we're going to say mark actions extension login view model. Okay. So then we're just going to say nav delegate dot on login success. Oh no, on login successful, and then in the on register, you could probably already guess on register tab. Actually, one thing we want to do on login register tab on login successful. This is going to look a little weird. I like prefixing each one of these methods with the actual name of the view itself. So like on login, this is the login screen on login. The reason this is going to become handy down the road is because we're going to have a lot of delegate methods being adhered to within each of these coordinators. You don't want to repeat yourself with these because it will clash with other protocols potentially. You'll see what I mean here in a little bit, but it does help to kind of namespace these a little bit. Oh, that's actually not the one I needed. I needed this. Cool. So now if we go back into our login view, spread this out a little bit, we can now say viewModel.email and viewModel.password. The button's going to say viewModel.on login tapped, viewModel.on register tapped. That should go away. We should be able to see some preview here after viewModel.init. We should be able to build this and then see a preview of this. Cool. So it's back to where we were. So now that we have that, what we can do, X out of some of this stuff, let's go back into our application coordinator. So the start auth right here, we need to, instead of this going to be one single screen, it's going to be a coordinator. So what we want to do is we want to hook up the screen that we just made into an actual coordinator object. So we're going to create a new file from template. We're going to make it a Swift file, AuthCoordinator. And this is going to hold on to all of the screens for our auth flow. Let's organize this a little bit better here and just say flows, and then move this down into the flows directory. Just in case, okay. So from here, we're gonna say class AuthCoordinator. Let's give us a little bit more room. AuthCoordinator inherits from BaseCoordinator. Want to make sure we have UIKit imported here. UI navigation controller is the presenter type, and then within we can say we can override the start method. Now what I do, just like in the application coordinator, we're going to have a extension showing screens. Then we're going to say extension AuthCoordinator, and this is going to be func show login screen. Let view model equals login view dot view model view model dot nav delegate equals self. Remember that nav delegate, we're delegating up to this coordinator object, so we have to label it as self. We haven't implemented the functions for this nav delegate yet. We'll do that next. Let view equal login view. And I'll explain this here in a minute. Let me just adhere to the delegate method. No, not capped. Also, just to reiterate again, it's important to have these marks in here because you can come up here and you can either hit Control-6 or you can click on this selection area here and it will actually show these little flags to organize everything pretty nice and neat. Okay, so on login register tapped and on login successful. We don't have anything to do. We don't have any actions for this yet, but now that login view model, when the user taps on things and it delegates back up to the nav delegate, the nav delegate is the coordinator, which will then handle these actions. Okay, so another thing too is we're using this hosting controller that we made the base class for. Then we're just setting the title like this. What you'll see in the future, in a couple of these future videos, is that we're actually going to be able to create a subclass of this to handle this kind of logic inside the controller. But I think it was important to show you that you can't just use this hosting controller out of the box. Then we are setting the view controllers, the navigation stack, to have one view controller, which is our SwiftUI's wrapped view within the hosting controller right here. Then all we have to do is say start is show login screen. And that is our AuthCoordinator, the very basics. So now what we can do is we can go into the ApplicationCoordinator. And instead of the start auth right here being one view, what we can do is we say let, or you just say AuthCoordinator equals AuthCoordinator. The presenter is going to be the original presenter that is within the ApplicationCoordinator. And the reason we can do it this way is because inside the AuthCoordinator, remember, we are resetting the entire navigation stack with the set view controllers. So even if the user was already on the home screen, it would just navigate away from that and reset the entire navigation stack. So we can reuse the same presenter for multiple root flows, which is pretty nice. Then we just say AuthCoordinator.start, and this is the important part. the application coordinator has to store this in memory. So we say self.store the AuthCoordinator. If you remember from the previous video, this store on the BaseCoordinator, we're just setting it to the child coordinators right there. And that's it. Now, one thing that we need still with this is that we need a way to delegate away from the auth flow to the main flow. So there's an end to this coordinator. To do that, what we are going to do is we're going to use the delegate pattern again. And we're going to say protocol AuthCoordinator. We need to use any object here so we can actually use that weak var. Structs cannot be weak. It's only reference classes, reference types like classes. I'm going to say func auth AuthCoordinator. Cool. Let's see, AuthCoordinator is ambiguous. There we go. Again, if we didn't use any object here, which references a reference type, we wouldn't be able to use weak var. Structs structs don't create strong reference cycles, but because we want these objects not to be structs and reference types, that's why we need to use this weak var here. Cool. Now this is going to be called from the on login successful, so we can use, what did I say, just delegate dot on auth coordination complete. Now I am passing the auth coordinator back in, and actually the reason I'm doing that is inside the application coordinator, when we are adhering to this, we're going to say auth coordinator delegate and auth coordination complete. What we're going to do here is we're eventually going to call the start method again. There's going to be an if statement in here that will determine whether or not the user needs to be logged in or not. Whenever you complete a coordination, let's go back into this. So whenever we complete this, we have to then remove it from memory. So we don't want to create any kind of dangling memory pointers or any of that stuff. We don't want zombie objects hanging around. So to do that, we need to make sure we do self.free this coordinator, AuthCoordinator. Now, sometimes you might think that you want to free all the coordinators from this. Don't do that. Free only the coordinators from memory that are being closed. If you free the root one, all the sub coordinators, if this has any sub coordinators in it, will also be deallocated as well. So from this point on, what we would do is we would start, call start again. It's going to come back up here. Eventually we'll have it if is logged in, and then it will go through the whole if else statement right here, just like that. We'll get to that probably in a future video. We're coming down to the wire here, but in any case, next what we need to do is we need to create our register screen. So let me close some of these tabs up here. Go into screens, create new group, register. It's going to be a new SwiftUI screen, just register view. And this is pretty much going to be very much the same as the last one. Instead, what I'm going to do is I'm going to actually start with the view model, now that I have that view, just so we have the state. Oh, view model Rob. There we go. in here. We need combine, import SwiftUI. Register view. Again, with the any object, just to make sure we can say weak var. Okay, so just like in the previous view model, we are just creating the state right here. I won't go over the published stuff right now. And then we created another nav delegate. And then we have a weak var nav delegate. Just like that. Now, just like in the last one, see, the nice thing about this is it is boilerplate, but at the same time, it's consistent. Consistent is very nice when it comes to this. It also helps teams stay on the same page and maintain what's called conceptual integrity. On register tapped, I'm going to say registration successful equals true. Okay, so just a quick overview of what we just did. We are creating some variables for an alert to tell the user, hey, this was successful. Once this register tapped, traditionally in the actual real world, would spawn off a network request. And then once that came back, you would handle either the error and showing an alert for the error, or just tell them an activation email has been sent to this email. And we're going to then show the alert from here on out. The alert is eventually going to be the thing that actually calls the nav delegate to take us back to the login screen. Eventually down in another video, we're going to have a confirmation email screen that has a code in it. But I'm going to leave that to another video because that's a reused screen. And it's going to be cool to see like how we can refactor the code base to utilize that screen using this pattern. So for right now, we need to go back into the register view. And then we need to say let's give us some more room here. ViewModel. And we're going to say, just like in the last one, we're going to have a VStack. And we're going to have a spacer at the top. Value. This one, we're actually going to give some padding. we're going to have another password field for the confirm password. But this time we're going to have a placeholder of confirm password. Then we're going to have a button for the register button. ViewModel.on register tapped. Then a spacer, and at the very bottom of the screen we're going to have another button that takes us to the login screen. Okay, then the very last thing we have is we need to, we're going to set the padding again. 50, so the width is the same. Okay, then we're going to do .alert. And what do we got here? Actions, message. Right here. I'm going to say view .alert title, view model .show alert, and then our action is going to be a button that just says okay. It's roll, cancel, but the action of the button, we don't really need cancel. We can just do none. What's the default to this? That's fine. If ViewModel.registration successful, then ViewModel.navDelegate.on registration complete. This should technically go in the view model if we're delegating back out. So we can say func on. Actually, what we could do, because this on login tapped, because we want to go to the login screen after the registration is successful right now, we just reuse this function and just say ViewModel.on login tapped. And this has to be a bound value, a binding. That should go away. And now we just say ViewModel.init. And that should be enough. Let's hope the build gods are in our favor. Cool. And then if we hit refresh on the SwiftUI previews, we should get the registration screen. Looks good to me. Okay, so back into our AuthCoordinator. So we created the screen. Now we have to add it to the navigation. So we got func show register screen. And we basically do the exact same thing we did before. Let view model equals view.viewModel, view model.navDelegate equals self let view equals register view model. As you can tell, what I'm doing here, the coordinators also function as a place to define the views as well. So it's not just navigation logic, we're actually configuring and setting up all of the views to be used in the navigation as well. The nice thing about this, as you'll see in a future video within this series, is that this is pretty powerful because you only have one location across the entire code base that will ever create that screen. So if you need to change the way that configuring the screen is, you just change it in one spot. Rather than trying to create different locations and using it in different ways, you have one spot to configure it, and that creates a whole lot of time saved in the future. For this one, we're going to say HostingController, same as the login screen, ViewModel. And then we're going to say controller.title equals register. And then presenter.pushViewController this time. True. And we have to then on login register tapped. So now that we have that, back to our actions for the login, we can now say show register screen. And if we collapse that, register nav delegate, register complete, login tapped. Okay. So on register complete, on register login tapped, we're going to show login screen. And then on the register complete, this is where we're going to delegate back out to the application coordinator. So now that we have the delegate up here, right here, we can then say when the registration is complete, the coordinator is technically complete. We are now authorized. So we need to say delegate dot on auth coordination complete and pass ourself in right here. Cool. So same thing. So when register is complete, actually, nope, scratch that. On register complete is just show login screen again. My bad. And basically the reason for that is, technically speaking, when the registration is complete, some apps do pass you out of the auth flow and into the app itself. They'll save credentials locally during the registration process, and they will automatically pass you into the home area. In this case, we're not going to do that. The reason this was a little confusing at first is because eventually this registration complete is going to lead us to the email confirmation screen. Not part of this video, but part of the series. So for right now, we're just going to show the login screen upon both actions. And then once the user hits the login button from the login screen, that's when the coordination completes. So we need to go back up to our application coordinator. And if you're wondering how I'm accessing this little view right here, it's Command-Shift-O, and then you can just start typing in whatever file you are looking for, hit enter, and it will take you there. Okay, so we have start auth, this right here. One thing we have to add is auth-coordinator.delegate equals self. Now the auth-coordinator is hooked into this, and it's going to hit start, and then it's going to come up here. From here, what we're going to do is we're going to say func start main. And I won't create the actual coordinator because I'm running out of time here. So what I'll do is I will recreate that test screen. And then we'll say because I'm not using a view model, we can't use our custom hosting controller. So I'm just using the regular UI hosting controller here as an example. And then we're going to say presenter.set view controllers true. And then what we can do is after we are finished logging in, instead of hitting start, which will eventually have the conditional in there on what flow to then pursue down, we're just going to say start main, which technically speaking, this is actually a valid use case. So you could just say start main from where the auth coordinator ends. It depends on how you are saving and handling the auth state. Sometimes it's nice to have the added check with an if statement in here to double check that your credentials actually saved correctly. And if they didn't, it would just go back to the auth screen. And then you could show some sort of error toast alert message to tell the user, hey, something happened, an error happened, please try logging in again. But in this case, it is fine for us to just hit start main. Now that that's done, what we should see is we should see this screen able to go into the register screen, back to the login screen, and when we hit submit, it should bring us back to this hello world. In that case, let's go back into our simulator here and hit play to refresh. Oh, don't want that. Move that over here. Okay, and there you have it. So we have a navigation app here. We can hit register, brings us to the registration screen. We can go back. It's pushing it on top. When we hit register, we have the alert that shows up. Brings us back to the login screen. We can hit register. We can navigate back using this button again. Now, if we hit submit, it brings us to our home screen. Well, what will be the home screen. And that is our auth flow, minus the one screen we're making in a future video. That's it. From here on out, the next video, we're going to create the main screen with the tabs at the bottom. AKA, we will, if I can resize correctly here. AKA, we will be creating this screen right here with the home screen and the tabs. From there, what we'll do is we'll also create the account screen so we can log out and close the loop with logging in and logging out. So hopefully, just to reiterate, just so hopefully that all makes sense to you. So what we did again with this flow is we've got this root flow here with the application coordinator. And all we did was we created the auth flow with the registration and the login screens. And we allowed the user to tap submit to then enter what will be the main flow. Right now, it's just a placeholder screen. Again, this confirm email screen right here will be done in a future video. So I'm hoping that this is starting to become a little bit more clear on how things work. But basically, once you have these flows in place, it's drastically easier to handle the navigation logic. And as you can see through the code, once you kind of do it once, it kind of sticks with you because creating the screens is fairly easy. Having one spot in the app for each screen's configuration is also very useful. But in any case, I hope you got some good information out of this. Let me know in the comments section if you need me to reiterate or expand on any of the concepts I'm talking about right now. And in the next video, we will handle the main flow. So until then, happy coding.